Hello everyone, welcome to the IEEE OES short-term course on AUV modeling. My name is Vallabh Devakar. I am a research scholar at IIT Madras and I am also the IEEE student chapter treasurer. I will be covering the autonomy module of this course. Without further ado, let's get to the technical content. Let's look at the outline of this module. First, we will look at the introduction, structure of autonomy, the feedback loop in autonomous systems, the 4 pillars of autonomy, the perception and sensor module. Then we look at the navigation, localization and SLAM. Then look at the path planning and obstacle avoidance systems. Then we will look at the control systems. And finally, we will go over the summary of this entire module. Coming to the introduction. To understand the main purpose behind autonomous systems, we need to first consider what are the tasks or the missions that a particular AUV needs to accomplish. The types of missions that an AUV system will need to accomplish can range from exploration and mapping of ocean floors, data collection such as environmental monitoring, search and rescue operations, military and surveillance operations, pipeline and cable inspections. You might notice that for all of such applications, the key aspect is that we need a limited human intervention. The AUV system or the autonomous system needs to have a perception module and a decision-making capability. To execute such complex missions, the AUV system needs to have the autonomy module present in it, and that is the key motivation behind the autonomous module. Let's look at the structure of the autonomy. On the left side, you will notice you have the higher level controls. These will include some microprocessor boards such as the NVIDIA Jetson Nano or the Raspberry Pi. These processors will mainly contain the codes or the higher level autonomy controls which will carry out the tasks such as sensor data processing, motion planning and control algorithms. On the very right side, you will notice that we have the lower level control. This includes the controls given to the thruster commands or the rudder commands. In the middle, to send the commands from the higher level control to the lower level control, you have a middleware. One of the popular middlewares is known as the Robot Operating System or ROS, which is completely open source and is widely used in robotics community. Now let's understand the feedback loop in autonomous systems. For any autonomous system, the most important aspect is the sensor data. This sensor data is sent to the decision-making module of the autonomous system, which will do something called the motion planning. The motion plan will tell the autonomous system from a given start state how the system can reach to its target goal state. To achieve this task of reaching from a start state to a goal state, the system needs to know its own current location, which is achieved through the navigation module. The navigation module further gives these commands, gives the information to the control module. The control module gives the commands to the AUV or the autonomous system, which change the AUV's location and move it towards its goal. As the AUV progresses towards its goal, the sensor data it collects is also varied This varying sensor data leads to a varying motion plan. This varying motion plan leads to different locations of the AUV, which is again interpreted by the navigation module, and further it leads to different control outputs. And this loop keeps on going, and that is the feedback loop in the autonomous systems.